Namaskar. Lightning protection devices, surge protection devices, and earthing. This plays a very important role in railway signaling system. In this presentation, we will deal with LPD, SPD, and earthing that is used in railway signaling systems. What is lightning and what is surge current? Lightning is basically because of a cloud burst. Cloud burst results in lightning. It possesses unacceptable risks for electronics and communication system. In railways, we use a lot of electronic equipments, let it be in electric EIs, EIs or SSB, UFSBI, or even in normal fuses. All these things can be affected because of lightning. A single direct strike of lightning can result in physical damage to the structure, which may result even in fire. The product may get damaged, and communication downtime will be there. And if earthing is not proper, it can even be there can be a chance of loss of life. While surge is a very short burst of voltage, sudden increase in voltage, you can say sudden increase in voltage, it has to be suppressed, उसको control करना पड़ता है. It can cause equipment failure or total hangover of the system. The duration of the surge can be very less, of just to the range of 1 millisecond, but it can create a major disaster and failure. Surges are induced in nearby AC power lines or even in our cabling lines, basically due to whenever there is any cloud to cloud burst, cloud to ground strike, that is lightning which comes from cloud to ground, or due to self-inductance whenever power is switched off and on due to non-zero crossing point of a sine wave. So whenever you switch on any power supply, a sudden increase in voltage can result in fuse blowing off also. That is also a type of surge. Which equipments we need to protect from lightning and surge protection? These: IPS, EI, SSDAC, MSDAC, LED signal lighting, and other electronic equipments which are used in railway signaling require protection. The internally used surge protection components, which are generally provided in at the equipment level, are not sufficient to protect the equipment. जो भी equipment हम जो भी surge protection devices equipment के पास लगाते हैं, वो शायद बस नहीं होगा. So we need to have more protection from lightning and surge protection. Hence, suitable surge protection arrangements are required to be done at different levels. Different levels of protection are required for these equipments. So generally they are classified as Class A, Class B, Class C, and Class D protections against lightning and surge protection. If you classify them like this, lightning and surge protection devices, you can say external protection and internal protection. When you talk about external protection, it is called Class A protection, while internal protection can be Class B, Class C, and Class D. All these are equipments are how this system works. I will give you a very simple example through which you can understand how Class A, Class B, Class C, and Class D are protecting our railway signaling systems. In this, you can see whenever there is any rain, you use an umbrella. This is an external protection which is protecting your whole body. So this is simply a class A protection. जब भी बारिश गिरता है वो आपके ऊपर नहीं गिरेगा. So almost more than 50 to 60% of rain that is falling on you is diverted to ground because of this umbrella. Next, you have protection from rain through raincoats. This raincoat you can see is class B and class C protections, while inner garments which you wear can be said as class D. So umbrella, you can take it as a class A protection. Raincoats are provided here are as class B, class C, and the inner garments that you provide can be class D protection. Going further, here you can see the class A protection. This is the building, our signaling system or relay room, where you have a protection. This class A protection is generally provided for the whole building. If the building is big, we need to provide more class A protections. Whenever this is provided, whenever there is lightning, almost 50% of the current goes through in this way to earth, even there is a counter provided. So it is an external lightning conductor on top of the building, connected through a down ground to the ground through our conductor. Generally 35 square conductor, copper conductor is used, or a strip is used to take the lightning current onto earth. The main parts include strike terminator. So this is your strike terminator. This is your ground conductor along with a counter. This counter is provided outside the building, and then ground earth, which shall be less than 1 ohm. 50% of lightning energy or current is connected to ground with the help of a lightning class A protection. Now, how much current is provided? For example, there is in general in India, whenever there is heavy lightning, it is observed that about 200 kilo amps of current is developed. That is a maximum current that is observed in India. So let us say 200 kilo amps, that is around 2 lakh amperes of current is developed. So in that almost 50%, that is 100 kilo amps of current is directly sent to earth if you have a good class A protection. Now coming to class B protection, it is connected to the mains input supply and before the equipment. It is connected to the mains input supply, that is 230 volt supply which you bring. This class B protection is connected in that place. And the type of technology that is generally used is spark gap technology, which is employed with an arch chopping principle. It is chopping, that is cutting out the uh, lightning, arc chopping principle. It is designed to handle lightning current pulses with a waveform of 10 by 350 microseconds. Now, what is the meaning of this 10 by 350 microseconds? Here I have given you a simple small example. This is the normal voltage that is going on. But because of lightning, there is a sudden increase in the current, sudden increase in the voltage also. And again, it comes down. So what this will be for a very small microseconds. So when you tell it is 10 by 350 microseconds, it means that let us say 230 volt supply is available with some 10 to 20 amps of current. Suddenly, because of lightning, the voltage has increased abnormally with a current of about 200k 200k amps of current, 2 लाख एम्पियर करंट का जनरेशन हुआ है बिकॉज ऑफ लाइटनिंग, और वो 10 सेकंड में इंक्रीज हुआ है फ्रॉम 230 volts, it has increased to some 50,000 volts within 10 microseconds, and it has stayed there for a time period of 350 microseconds. So what is the meaning? Normal 230 volts 10 amps has suddenly increased to abnormal voltage and abnormal current within 10 microseconds and stayed there for 350 microseconds. 350 microseconds तक वो वोल्ट करंट और हाई वोल्टेज और करंट था. अगर वैसा है तो भी आपका लाइटनिंग प्रोटेक्शन डिवाइस जो है क्लास बी, वो आपके इक्विपमेंट को प्रोटेक्ट करेगा. ना अगर वो लाइटनिंग बहुत ज्यादा देर से है, यानी 350 माइक्रोसेकंड से ज्यादा है, लेट अस से इट इज फॉर 1 सेकंड, तो ये सिस्टम प्रोटेक्ट नहीं करेगा. This is maximum pulse wavelength form that is formed. That is why this in India this system is enough. अगर आप इसका कनेक्शन देखोगे तो हाउ दिस कनेक्शन इज डन, it is connected between phase and neutral. Here you can see this is one class B protection LPD. This is another class B protection SPD. So these two are class B protections. The main 230 volt supply is bought through the fuse and given it to the one end of class B. It is between phase and neutral. So you can see yellow is phase, black is neutral. It is connected in parallel to phase and neutral. This rate will be greater than 50 kA. While the second one is provided between neutral and earth. Neutral and earth. And this is also having a 10 by 350 microseconds waveform. So these two are 10 by 350 microseconds waveform. अगर कोई lightning heavy current आ गया and within 10 seconds it has increased and stayed there with that high current for 350 microseconds, these two will protect the system. अगर ये माइक्रोसेकेंड्स में वोल्टेज रहता है, if the voltage is staying there in microseconds, then it should be even quicker to operate. That is, it will operate in less than 100 nanoseconds. 10 to the power of 6 is micro, nano means 10 to the power of minus 9, while the symbol for class B is this one. Surge protection devices can protect the electronic equipment from potentially destructive effects of high voltage transient currents. These features of this SPD are rapid operation. I said it will be in nanoseconds, accurate voltage control, and automatic resetting once the over voltage has ceased. So heavy current आया तो ये protect करेगा. This will protect, and when the current is not available, subside हो गया तो automatically reset हो जाएगा. That is the specialty of your SPDs that are or LPDs that are provided in the system. If you take this, this is the class C protection. It is again provided at the equipment input level between line and neutral. So here line and neutral, it is provided between them with a it can protect range up for greater than 50 kA in input supply and before the equipment. It is also provided at the outside of the distribution panels. Whenever supply is going outside, 24 volts external, 110 volt DC, 110 volts AC, which are going outside, then also we provide these class C protections. It is generally a single compact metal oxide varistor. It shall be voltage clamping device and thermal disconnection type. It also shows an red indication whenever there is a failure. Thermal disconnection or device when it starts having leakage current due to aging or handling several surges. So whenever there is heavy strike regularly, this can get damaged and red indication will come. So you need to replace this when there are heavy lightnings regularly after some time. It is also provided with a potential free contact for remote monitoring, and a number of MOVs shall never be connected in parallel. एक ही MOV बहुत ज़्यादा MOVs connect नहीं करना चाहिए in parallel. In IPS, if you see, we are using class B and class C. So this is an IPS, class B, class C, earth terminal, and class D is also provided inside the SMPS panel. Generally, these are MOVs provided. But nowadays, we are providing class C only. This is an example of how LPD and SPDs are connected in IPS. So when supply is coming line and neutral, we have a 63 amp fuse. From there, the supply is going to IPS. Neutral is also going to IPS. But in the middle, we have one class B with which has a protection level of greater than 50 kilo amps. 10 by 350 microseconds waveform, while one at greater than 100 kiloamps is provided between neutral and earth with the same waveform. While the waveform will be reduced for class C, it is 8 by 20 microseconds with a greater protection level of greater than 10 kA. उससे भी कोई voltage leak आके IPS हुआ, then you have another range of protection which is called class C protection, class D protection. So here you can see a simple example of SPDs. Here you can see the PFC contact which can be connected to your data logger for remote monitoring also. Here you will get the red indication whenever there is any failure of your protection. This is the second stage of protection, that is point operation supply. Your supply is going outside. So there we need to provide protection here. Here you can see class C protection is provided. One SPD is provided between positive and negative. The second SPD is provided between positive and earth, while the third one is provided between negative and earth. So generally it is must that three SPDs are used for each power supply that is going or connected to outside world. This is the class D protection. Nowadays, these MOVs are generally replaced with the class C protection only. The device power line protection shall be of class D. It consists of a combination of metal oxide varistors and gas tubes. This should have all the features as mentioned above for class C also. All external data or signaling lines are connected to electronic equipment should be protected by this arrangement. This is also available, you can see, in LED signals. But generally we should be very careful. If this gets short circuited, your UCR can pick up even when your bulb is not glowing, because this may have become defective. Remove them in such case. Summing up the above what explanations we have seen, class A is provided on top of the building, and 50% of lightning energy or current is connected to the ground, while class B is connected to the mains input supply and before the equipment. It is connected between phase and neutral with a greater than 50 kA capacity and 10 by 350 microseconds waveform. It is also connected between neutral and earth with a greater than 100 kA and has 10 by 350 microseconds waveform. It is designed to handle a lightning current pulses with waveform of 3 by 10 by 350 microseconds. Class C protection, it is also provided at equipment input level between line and neutral and input supply and before the equipment. This is a protection level of 8 by 20 microseconds. All external data signaling lines connected to the electronic equipment shall be provided with class D protection. As per signal engineering manual, what is the uh, periodicity schedule of maintenance of lightning protection devices as per SCM? So let us in periodicity for a technician, signals shall be monthly, SSC JE shall be quarterly, while SSC in charge shall do all the required checks once in half yearly. What are the checks that have to be done? SPD, B and C type at 230 volts entry level indications are okay or not. Any failure indication shall be replaced with a new SPD. All the connections to the SPD are intact. While schedule code E2, here the sectional SSC is half yearly, while in charge SSC is yearly. What needs to be checked once in half yearly? SPD C type at the output side of DC supply indications are okay. Before onset of monsoon and after every lightning, it has to be verified. So whenever is sudden rain, sudden lightning, it is better to go and check the protection provided there. Connections to the SPD are intact or not shall also be checked. while once in a year the following things shall be done. Proper rating a type of SPD is used. If not used, it shall be replaced. Potential free contacts which are wired shall also be checked for validation through data logger. Thank you.